In this lesson, we're going to walk through creating prefix lists on Arista switches. Prefix lists are similar to access lists. Just like ACLs, prefix lists are leveraged to identify something for which an action can be taken. Where access lists are often used for security or quality of service needs, prefix lists are most often leveraged for influencing routing. The processing of a prefix list is the same as an access list, where they are both processed sequentially, starting at the top and working down to the bottom. Working through each line of the prefix list, we check for matching criteria. If we don't match the first line of the prefix list, we continue processing top down until either we find a match or we reach the end of the prefix list. A significant difference between a prefix list and an ACL is that once we reach the end of an ACL, there is an implicit deny. Prefix lists do not have an implicit deny. We simply reach the end of the prefix list and then take no action, having not found a match. Arista switches support both IPv4 and IPv6 prefix lists. For IPv4 prefix lists, we create them in the switch's global configuration mode. This is slightly different for IPv6 prefix lists that are created in a specific prefix list configuration mode. The way we write out our IPv4 prefix lists are a bit different than how we create or edit access lists. We'll use the IP prefix-list command with the name and then a sequence number and the host or network that we're targeting for action. Let's walk through a simple example. So on our lab switch here, switch 1, we'll get into configuration mode by typing config, enter, and then IP space prefix dash list, and then question mark, where we're asked to provide a list name. Let's call it example 1, space question mark, and we can see our options are deny, permit, or sequence number. So if we enter sequence 10 space question mark, now we see we have a deny or permit left. So let's do a permit and then a question mark, and we can see we can add our IP prefix or an IP address with the mask length. So let's enter 10.11.11.0/24 and hit enter. To create another line for that same prefix list, we repeat the steps. IP prefix dash list, example 1, space, and then sequence number, and this time 20, permit 11.10.10.0/24. And then we can issue the command show IP prefix list to see our newly created example 1 prefix list. So right here from where we're at in configuration mode, we can issue the show command, and it'll be show IP prefix dash list, enter. And we see the two lines of our example 1 prefix list, sequence 10 and sequence 20. Since these are processed in order from top down, we may want to insert a line near the top. The reason for such an edit is usually because we know the line we are adding will be matched frequently, and it will save us processing time if we put frequent and specific matches near the top, since those get processed first. If we want to insert a line near the top, we can leverage the sequence number option, much like we can with ACLs. So let's add a line in between the two lines of our example 1 with an IP prefix dash list, example 1, sequence, and here we'll use 15, permit, and then a subnet. Let's just create a 100.11.11.0/24, enter. Now if we reissue the show IP prefix dash list command, we'll see we have 1015, our newly added one for the 100.11.11.0/24 subnet, and then our sequence 20. There is another key difference between prefix lists and access lists. In prefix lists, we have an option at the end of each line where we can adjust the coverage of the subnet mask or provide it a range. In other words, we can match on the prefix range as either GT for greater than, EQ for equal, or LT for less than. Let's add another example to our prefix list to step through what that looks like. Type IP prefix dash list, example 1, space, and then we'll just put in a permit space question mark, and we can add our subnet. So let's add a 100.100.100.0/24 space, and now let's put in another question mark. and we can see our operators here. We have EQ for equal to, GE for greater than or equal to, and LE for less than or equal to. The GE, greater than or equal to option, means that the range is from our starting point up to and including a /32. The LE, or less than or equal to option, means the range is from our starting point and then working down the subnet mask length. And just to give a little bit more flexibility, we can combine the use of the GE and LE options to be where our range starts with the GE or greater than or equal to option, but then stops as LE or less than or equal to another value. An example is always helpful. Let's add to the end of this line a GE space 25 space LE space 30 and hit enter. Now if we reissue our show IP prefix-list command, on sequence number 30 we see the newly added 100.100.100.0/24 as long as it's greater than a subnet mask of 25 but less than a subnet mask of 30. And that greater than and less than also means equals. So it's specifically greater than or equal to 25 or less than or equal to 30. And notice for this last line addition, I didn't specify a sequence number. The switch did it for us automatically, assigning the sequence number 30. Now let's use our prefix list to influence some routing. We'll call this prefix list in a route map. So let's create a route map. We'll call it example 1, route-map example 1 space, and then we have to create a stanza. So let's do a permit 10, enter. And then we'll type in our match criteria. Here it'll be match IP space address, and then a question mark shows us we have the option to match against an IP access list or a prefix list. So if we type out the keyword prefix-list space question mark, we can see we're prompted to enter the prefix list name. So we'll use our example of example 1 and hit enter. Now if we exit of route map configuration mode and just simply type show route-map, we see we have our route map example 1, our stanza is permit 10, with the match clause of our IP address prefix-list example 1. Now, as an example, our routing protocols, such as BGP, could call this route map that then reference our prefix list to determine which routes we'll keep from a specific peer or perhaps a peer group. During this overview, we found that prefix lists are similar to access lists, but the matching happens only on subnets rather than on specific ports such as TCP or UDP port numbers, and that the most common use of a prefix list is to influence our routing tables.